In this clip, we'll take a look at how to handle a problem that mentions money is being compounded annually. We'll solve a problem in this side, and then I'll get you to try a practice problem on paper, and I'll post the solution down here a bit later. Let's get started by having a look at our problem. Sammy invests $800 at an interest rate of 4% per year, compounded annually for 5 years. What amount does she have after 5 years? As soon as a problem mentions that there's money being compounded, I'm almost positive I'm going to have to use my compounding interest formula. So let's go ahead and have a look at that formula again. And it looks something like this. And let's do a refresher on each variable in that equation. The first variable, or A, is the amount of money that we finish with after the investing, and that's in dollars. The second variable, P, is the principal. P is the amount of money that you start off with before the money begins to grow, and that's also in dollars. I is our interest rate, and that's expressed as a percentage. And finally, for compounding interest, we have this variable called N, and it's the number of times that the money is compounded. Let's start this problem off by listing our givens. The first number I come across is the $800 that Sammy invested. So we started off with $800, and that will be our P, or our principal. So I'll just make a note that the P in this question, the principal, is $800. The next number I see is the interest rate, and it's 4%. That'll be my I. And I'll have to do some converting on that a little bit later because it's in a percentage and I need it in decimal. And finally, I need an N value. N is the trickiest variable in this equation because it's the number of compounding periods. So in this question, it's being compounded once per year, or annually, for 5 years. Once per year per 5 years. Well, that's 5 compounding periods. So in this question, my N will be 5. And I'm being asked to solve for the amount, or the A. So let's get started with step 2, where I'll convert this into a decimal. To convert 4% to decimal, I'm just going to write down the number 4 without a percent sign. And then what I'm really doing is dividing the number by 100, which means I'm sliding a decimal point 2 places to the left, and I arrive at an answer of 0.04. If you need help converting percents to decimals, please check out an earlier mini clip on converting percent to decimal. Okay, now that my rate is converted to decimal, I can go ahead and start plugging in my values into the equation and solve for A. In this step, I'm just going to use the compounding interest formula and plug in the values that I know and solve for A. P was found to be $800. Then I have a 1 plus I, which I just converted in step 2 to 0.04. And finally, N, this exponent, which I found to be 5. So the next thing I want to do is I'm going to clean up this bracket a little bit before I do the exponent math. So I'll add 1 and 0.04. So I'm going to say 800, and 1 plus 0.04 is 1.04. And I still have that 5 exponent. And then finally, to solve what I have left, I'm going to use my calculator. I'll do 1.04 to the exponent 5, get my answer, and multiply it by 800. 1.04. I need this x to the y button for the exponent, then 5. Multiply that answer by 800. And there's my answer, $973, and we'll say 32 cents. And 32 cents. So this money has grown from $800 to $973.32 after 5 years. And that's my final answer. The last thing I'll do is add a concluding statement that says just this. Therefore, she has $973.32 after 5 years. And that's my finished problem. And now it's your turn. I'll present a problem here, and when you're ready, give it a shot on paper, and then I'll post the solution down below. So your problem reads like this. Jill invested $100 at an interest rate of 8% per year, compounded annually for 6 years. What amount does she have after 6 years? Okay, go for it. And here you have it. Your answer is $158.69. We used the compound interest formula, and we listed our givens. Then we converted 8% into a decimal, and finally plugged in our values for P, I, and N, and solved for A, $158.69.